All right, notes 10-2. And so flip over, we're doing word problems. We're still just doing vectors. You just got to pick out the vector information. Everybody ready? 10-2. All right, so all these are best if we're going to be working from north, or we're going to be working from east. You confused yourself? And I'm going to write X right here because they're referring, is everybody with me? They're referring to the X-axis. Right here, it says to the X-axis. So the X-axis is really your east, right? East direction. But I'm going to write X because they say to the X-axis. So we have two forces. I'll draw the forces in red. So one is 20 newtons and 10 newtons. And they don't tell you which one goes to which, but the 20 newtons goes to the 0 degrees, and the 10 newtons goes to the negative 30 degrees. So we're going to go 20 newtons is 0 degrees. And it's 0 degrees to the X. Yeah, it goes in order. It goes in order. So we're going to do 20 newtons, at 0 degrees to the X-axis. Sometimes it'll be to north, so you got to pay close attention if they're measuring from north, or they tell you to measure from the X-axis. And this one they tell you from the X-axis. So it's 0 degrees to the X-axis. So now we're measuring off the X-axis because they tell us to. But they don't tell you what to do if it just says it's heading 58 degrees. Well, that means it's from north. All right, normal, just regular is from north, but if they tell you, do what it says. Now it says it's negative 30. This is where it gets a little tricky because we would think because most of the time it's from north in the clockwise direction, negative 30 would be in the negative direction. But if they tell you with respect to the X-axis, up is positive, down is negative. You get it? I'll go back to that one in a second. So we're going to go negative 30, 10 newtons. So this right here is 30 degrees. So I'll say it again. When it says to the X-axis, positive is up, negative is down. If I was doing to north, left is negative, right is positive. So just kind of put yourself on the coordinate plane and think, okay, if I'm going this way, my negative is to the left. If I'm going this way, negative is down. All right, so it doesn't work exactly like the trigonometry stuff did with counterclockwise and clockwise. So that's a little tricky. All right, so now we're going to take this vector and we're going to add it to this vector. We're going to take this vector and add it to this vector, or you can do it the other way. You could add this vector to this vector. I always move this one over here. I just take the one going down and move it to the end of the other one. So remember to add vectors, you just do tip to tail. You just take this vector and put it on the end of that one. So I'm just going to move this one over, and here's my vector. Let me just draw a straight solid line. So, and I have a glitch in my board right there. So don't let that throw you off. A little glitch. See how right there it hops? See how it hops? It's weird. It's got this awkward little glitch right there. My line looks horrible. I can't make it look good. I sent in a request today because I'm tired of it. I was like, okay, this has to be fixed. All right, so this is 10 now, 10 newtons. Because did you see the parallelogram? You have a parallelogram, but really you're just trying to find the resulting vector, and the resulting vector goes from here to here. Your resulting vector goes from here to here. So I'm going to draw it in black. The glitch doesn't help. See the black line? That's your resulting vector. That's going to be the magnitude we're looking for, just like yesterday. And we're going to call this like your radius from the center. So just call that R. If you don't like R, you can use B. A, B, and C or something. I don't know. If you want to label like A, B, and C and call this B, you can, but in the notes I use R for radius. Can we do Pythagorean theorem? Good. So what I'm going to do, just to make this a little bit clearer, your picture might be a little bit better than mine. I'm going to take my triangle and draw it out here a little bit better. This is 20. This is 100. This is R. What's this angle right there? Good. It's 150. How do you know that? Good. See the pair. Hold on. You got 50 questions. Let me finish explaining. All right. See the parallelogram again? See the parallelogram? Well, if this is 30, what does this one have to be? 150. You just subtract it from 180. Oh. You're like, why did you put so many zeros? That's 10 with an extra 0. I don't know why I started it. He taught me into the Pythagorean theorem. Sounds like a good idea. Okay. I did. I'm just making up stories because I don't know why, really. All right, so what are we going to use? Law of cosine. Right, law of cosines. It's in your notes from yesterday. Go back and look it up. Go back and look it up real quick. It's in problem number 8 from yesterday's notes. So go look it up if you don't remember it. Go look up law of cosines and use law of cosines. So look at number 8 from yesterday's notes. You got it? Good. You remembered it? That's awesome. Hi. Yeah. See that glitchy glitch? Like I can tell you right where it's at. You can't really tell what the corner of that triangle where I was trying to draw my arrow. It keeps going. So, yeah. I don't have anybody 6th period. Does it take you a little while to do? Do you want to do it now? Do you want to do it now? I can pause my recording. I'm just recording, but I can pause it. No, because I think I can just, yeah. Yeah, like, what is that, 12, 15? Yeah. Or no? 20, yeah, you're right. All right, thanks. Right here, she can't fix my clutch. I want the clutch. I could have. You guys are so cooperative.
How many decimals do we write?
What?
How many decimals do we write?
3.
29.
What'd you get?
29.093.
29.093. Is that what you got? So we also have to find the what? It says find the magnitude and find the direction. So your direction is this little angle right here. So this little angle right here. So how can we find that angle? No, 30 is all the way to the 10 vector. We're trying to find this new direction right there. So it's going to be sine of 150 over 29.093 equals sine of whatever you want to call it. You can even call it theta. You can call it c. You can call it whatever you want to call it. Over, it's across from what? 10. So the sine of 150 over 29.093 equals sine theta over 10. And then cross multiply. 10 times sine 50 divided by 29.093. So it'll look like this. Good, but then you got to get theta by itself still. Inverse sine. Good. Okay, so we get to here. Some people are working ahead. How do we get rid of the sine? To get the theta by itself. Inverse sine. So theta equals inverse sine, no sine to the negative 1, arc sine, of whatever this is. And you can just put in your calculator like the whole thing like this if you want.
So it would be,
Question?
it would be sine, right? Sine of times 10.
So you got arc sine of 10 sine 150 over 29.093, and what'd you get? What'd you get from the x-axis?
0.728. That's what I got. Is that right?
What'd you get?
I got 0.0.7.
No, is it in degrees? So, good. Good. So you should have gotten 10, but it would be negative 10 degrees. I think it's approximate.
Miss, I have them in degrees.
Then retype it. Retype that. See what you did wrong right here. Okay, so it's negative 10x. What if I said, what's the direction from north? What's the direction from north?
It would be negative 90 plus 100.
It'd be 90 plus another 10, right? So it'd be 100 degrees from north. But since everything was done with respect to the x-axis, let's just keep it to respect to the x-axis. But if you answered this question and said 100 degrees to north, it would still be right. Did you use arc sine?
Oh,
Yeah, maybe. Try it again with arc sine. All right, try the next one. Set up your picture. Uh-huh. Uh-huh. Uh-huh.
So instead of doing...
Oh, I see what you're doing. Yep. Mm-hmm. Well, you don't, that doesn't go on the top. See how it goes out front? You're putting it on the top.
Oh, yeah.
See it? Yeah. There you go. All right, let me get a nice big picture going on here. What do you mean positive? Well, two forces with magnitude 400 and 300 at an angle of 25 and 70 respectively with to the positive x-axis, which just means over this side, just like the last one. So the 400 goes to the 25 degrees. Nice.
Okay, I have a question. So if I wanted to start like from here to make it easier, could I just subtract it and I got 45, so my first one would be here and the 45 be there. I would just like move, because yours is going to be like right here, right? Well,
So you're rotating it?
Yeah.
I don't think you can do that because I think your angle measures would then be off. You know what I mean? You could try it and then add it back or something, but... And then the other one's 370 degrees, so maybe right here. And this whole thing is 70 degrees. So what's the angle between the vectors? Good. So this measure right here between the vectors is 45 degrees. So I'm just going to take, remember I'm adding vectors. I'm adding vectors. So I'm going to take this vector and I'm going to put it at the end of this vector at 45 degrees. So just like a parallelogram. Because it would be 45 degrees off of here. This imaginary line that keeps going. That isn't a very, well, that's okay.
Why would you do that?
Because you're adding the vectors. You're adding vectors. This is a force and this is a force. And forces are vectors. Because it represents the magnitude of the 300 and the 400 and a direction. That's a vector. So we take one vector and we add it to the other vector, like yesterday, tip to tail. So I'm just taking this vector, and you could do it the other way. You could take this one and move it up there. Yeah, you could do that. It doesn't really matter. because the resulting vector still takes you to the same place. Because then what you're trying to find is your resulting vector right there. Right? Uh-huh.
How do you know graph would be
Because it says with respect to x from the x-axis, yeah. So it's positive direction, so positive is up.
so then
This one was negative, so it was down. 25 degrees. And then 70 degrees is up there more toward 90. All right, so I'm going to call this R. This is 300. What's this angle measure right here if that's 45? 135. Subtract it from 180, right? The vector, the angle in between the vectors is 45, so the measure of our parallelogram is 45 degrees. So this one's 135. Now you have side, angle, side. To find that, use your law of cosine. See it? What'd you do?
I found out that the regular triangle for the original first, it ends up being a 45, 90 triangle. So on the other side of that parallelogram.
Okay. All right, let's see if you get the same thing we do.
I mean, I would only look I don't know.
But where's, hi ma'am, where's the 45, 45, 90 triangle? Oh, like you, did you connect these?
And then if you made a parallelogram, it would be the same on the other side.
All right, and then you found out this distance? And I found out this, because you're really looking for this distance right there. Did you find that distance?
Oh, no. I found it.
I think you found the distance between the vectors versus the tip to tail. Yeah, somebody else did that in the last class. That's kind of normal.
How do you know this one is 45?
Because the whole thing's 70, and this is 25. So 70 minus 25. Yep. Any questions? Anybody need help? Timothy Cohen. For you. Okay, so the magnitude of our resulting vector is the square root. I don't think I'm going to have enough room to write it. Let's see how small I can make. Yes. And then look, I still ran out of room for the 135. You better really know what you're doing, because I wrote really small. And so 400 squared plus 300 squared minus 2 times 400 times 30 cosine of 135. Now what do we get? That sounds right. 647.847. And then it also asks for the direction, right? Find the direction and the magnitude. So sine of 135 over 647.847 equals so we're trying to find this angle if we're going from x, right? We're going to want to find that angle, and then what do we have to add to it to get from x? 25. So you got to find that angle, but then add 25 to it, and that will be your angle from x. Like that. So find this angle. right there. It's if I draw my triangle. Possibly. Yep. And then you're trying to find this theta right here. So we're trying to find this angle.
And that corresponds to 300, right?
And that is across from 300, yes. So then you get theta is arc sine of 300 sine 135 over 647.847.
So then you subtract it by 64700. Just keep that to
What I do? Yeah, I cross multiplied, divided by that, and then took the arc sine. So I skipped one step. Yeah. And then what do we get when we do that? Well, we have to add 25, so it's 44 degrees to x. Make sure you put to x, because if you put 44 degrees in general, it means from north. Our normal is from north. So this whole thing is from the x-axis, so we just keep it from the x-axis. So it's 44 degrees to the x-axis. Okay, any questions? All right, turn it over. The next two are easy. The third page of the note is just terms. Is that what you're asking? It's just terminology to know what things mean. No, we use 19. And then add 25 to it to get 44. All right, this one. Draw your picture. You have a plane flying south, right? Whatever. Yeah. What do you mean? We just have one more, like these two problems. So you have a plane going 100 kilometers per hour south with a tailwind of 25 kilometers per hour. So it's also going south. So if you just take the plane vector, add it to the wind vector, what do we get? Good. It's the magnitude of the plane plus the magnitude of the wind. Tailwind, that means it's behind it, from its tail. And which way is it going then? Which direction? So you just take the plane vector, add it to the wind vector, and ta-da. That's it. That's it. That's it. You just add the plane to the wind, and they're both going in the same direction. So you just add them together. Okay, what about the next one? Now you have a plane flying south at 100 kilometers per hour. But now you have a headwind. Good. So what would be the resulting vector? Yeah, the resulting vector would still be south. Got it? That's it. Now number C. What? The tailwind, though, means it's going with it. So you take the vector of the plane and you add it to the vector of the wind. Huh? Right, it's a vector. All right, last one. Set up your picture. Yep. Yeah. You need a graph. You always need a graph because your thing's either going to be from north or it's going to be from X. And to figure out your degrees, like somebody in the last class on their homework, they just drew a triangle out in the middle of space. And then when it said the direction from north, I'm like, well, how can you tell if you don't draw it on the thing, on the little grid? From the west. From the west. What are you laughing about? He's laughing at me. Math is so funny. What? It's going from the west. So if I'm coming from the west, which direction am I going? I'm going to the east. What's so funny? I want to laugh too. Just the problem. Okay, so plane with a heading of 130 degrees from north. So if it's 130 degrees from north, where am I at? Good. You're 40 degrees from the X. Good. And what's the speed? Still 100, right? And then you have a vector for the wind. And the vector for the wind is going which way? From the west. So it's going, good, it'll be right here on the x-axis, 25, going east. So now you just move this vector to the end of this vector, and you're going to have a long, skinny parallelogram. Long and skinny. Yep, this is 100. Just move that vector over to the end of the other one. Our resulting vector, I'll put in blue, goes from here to here. Fine when their question's gone, not that I'm saying anything about it. Darn glitch. So now we're trying to find R. So, that's your resulting speed of your plane. That's the resulting speed of the plane and the wind combined together because they affect each other, right? So you have a plane, and if you have a wind, they affect each other. So you have one vector plus the other vector. What, Brody? Oh. Oh, I'm sorry. Right. Yes, sorry. I didn't know. Thank you. Thanks for catching me up with what he was saying. we needed an interpreter, and we were speaking English, both of us. All right. So what's this angle? And so we're pretty much doing it the same, right, as before.
So we're going to be looking for that small angle right there, right?
For direction, you're going to be looking for this small angle, yes. But then once you get that small angle, what do you do from north? Did I make a mistake? Okay, go ahead. Because that means magnitude. Good question. I thought I did something funny again. I was like, what did I do now? It's okay. I'm used to myself a little bit. So the magnitude of R is whatever you get when you do all that off cosine. Were you guys in the same class last year? Oh, you started out in the same class. Then he moved to fourth period.
Oh, yes.
Uh-huh.
Oh, he was in my stage. No.
No, he was in fourth. Yeah. I think you were in fifth.
Yeah, I was in fifth.
All those 19 boys or something and 6 girls. I'm still traumatized. No, I'm just kidding. I'm kidding.
But really,
Okay, maybe deep down.
I'm not that bad.
It wasn't you. What do we get? You guys get it?
120. I got it.
120? That sounds right. 123 or 32?
23. Just 23.
23 what? 1? Oh, 229. So you can put 229 or 23, either one's fine. All right. So then what about our angle?
So now we do that thing.
You do that thing. Maybe. So we're trying to find this angle. Could be over. You see? So then you get 100 sine 140 over 120.23. This is a 4. And what do you get? That's a good question. Good, you add it to 9. Okay, how do you know which one to find? Because we're going to north, so find the one closest to north. This one right here. See? Okay, hold on. Hold on. Everybody listen, ready? So here, you got to focus on your vector. It's the blue vector. See the blue? That's your resulting vector. So you're trying to find what is your resulting vector from north. So if we find it to be x, and then add 90, we found it to north. This one right here. So that would be like if you wanted to use, you're just going in the wrong direction. I mean, no, it would be the same as this one. So you have to use, this is what Travis asked in last class. He's like, how do I know what triangle to use? That's it. And you use the triangle closest to whatever you're trying to measure it to. If you're measuring it to north, use the triangle closest to north. Most of the time, I can honestly say that doesn't even necessarily always work. I feel like you always use the triangle nearest to the x-axis.
So basically, it doesn't matter whichever triangle you use to get the result.
Right. The velocity, your resulting magnitude, you can use either triangle. But for the angle, you have to do the one. I think it always ends up being the one closest to x because you always have to know how far you are from x, even if you're trying to find it from north. Does that make sense? You can use this. You can use this triangle, and then you would have to add the 140 in this and subtract it from 180 to get this. Because this angle, even though it doesn't look like it, is congruent to this angle. And then it would end up being the same thing.
What I got was 8.
Right. Right. Or, right. You could subtract it from, I forgot you could subtract it from 40. Right. Yeah. As long as you get this is 32. Yeah, I forgot you could subtract it from 40. I think I even did that one time on one of the problems. Instead of adding up the 3 and subtracting from 180. Yes, it's 122 degrees to north, and you need to write to north. So 122 degrees to north. Because this whole problem was, to north. The next page is just terminology. Make sure you know your terminology. If it says which way is it heading, that means from north unless it says otherwise. And if it says what is its course, again it says direction of the actual path of the plane with the wind. That's the resulting vector, yes. All right, so make sure you know your terminology. See, this kind of answers your ground speed question. It's the actual speed of the plane with the wind as observed from the ground. Ground speed is the resultant of the airspeed and wind speed. What do you mean? That's your course. Direction of the actual path of the plane with the wind. That's your resulting vector. Snorri, I see.